Hello viewers, in today's lecture we are going to uh, take up an important topic in three-dimensional geometry, that is equation of a line passing through two given points. Now in our earlier video we have seen and we have derived the equation of a line passing through a given point and parallel to a given vector. Now here we have a line uh, which passes through two given points. So let us take a line, say this is a line and say this line is L, and let us take 2 points A and B on this line, right? So let us take A and B as 2 points which lie on this line L, and say the coordinates of these 2 points are x1, y1, z1, and this is z1, and here we have x2, y2, and z2, right? Now let us take an arbitrary point P on this line, or we can say that this is a general point on the line having coordinate x, y, and z, right? So what we have here, we have a line L. This is a line L, and we are interested in finding out the vector equation and Cartesian equation of this line L. And what we are given, 2 points A and B, which lie on this line, right? And P is any arbitrary point on this line L, right? Now let us join these points by this point O, and suppose we join A with O. Similarly we join A with P, and let us join this point B with point O, right? Now here we have three vectors, right? So we have vector OA. Vector OA is x1 I cap plus y1 j cap plus z1 k cap, right? And let us say OA is vector A, right? So let us take OA as vector A. Now let us take vector OB as vector B. This is vector B, and it is x2 I cap plus y2 j cap plus z2 k cap, right? Now let us take OP as vector R. OP as vector R. This is vector R, and it is xi cap plus yj cap plus zk cap, right? Okay. Now viewers, here we observe that the points A, P, and B are collinear, right? They are collinear. It means these 3 points lie on the same line L, right? Now AP, the vector AP can be written as OP minus OA. That is, vector AP can be written as position vector of P minus position vector of A. So OP is vector R, and OA is vector A, right? Now we can find AB, and AB is again, by the definition of position vector, AB can be written as OB minus OA. Now OB is vector B and OA is vector A, right? Now the vector AP and AB are parallel, right? This vector AP is parallel to vector AB. So therefore, by the concept of parallel vectors, we can write AP as lambda times of vector AB, right? We can write AP as vector AP as lambda times of vector AB, where lambda is some scalar. It is a scalar quantity, and here for AP we can substitute r minus vector r minus a vector, and here we have vector AB. AB can be written as vector B minus vector A, right? Now if we simplify this expression, we can write vector R as, if we take this vector A to this side, we have vector A plus lambda times of vector B minus vector A. So viewers, this is the vector equation of a line which passes through two given points. Now let us find the Cartesian equation of this line, right? Now this is the vector equation of this line L, and let us find the Cartesian equation. So here for vector R, if we write xi cap plus yj cap plus zk cap, then here we can write for vector A, we can write x1 I cap plus y1 j cap plus z1 k cap, right? And plus lambda times, lambda is a scalar, and for it is lambda times, we will write here for vector B, we can write it in the form of components, that is x2i plus y2j plus z2k, right? And minus for vector A, we can write x1 I cap plus y1 j cap plus z1 k cap, right? Now if we simplify this expression, we get x1 plus here we have x1 I cap plus y1 j cap plus z1 k cap, and then we can write lambda x2 minus x1, this is a lambda times x2 minus x1 I cap plus lambda times y2 minus y1 j cap plus lambda z2 minus z1 k cap, right? Now here we can write here we can write x1, this is I cap, and here also we have I cap, so we can write x1 plus lambda times of x2 minus x1 I cap, right? Similarly we have y1 plus lambda times y2 minus y1 j cap, and then we have z1 plus lambda times of z2 minus z1 k cap, right? And here we have xi cap plus yj cap plus z k cap, right? So here we have this expression. Now if we compare the I components, j components and k components on both sides, then we see that x is equal to this expression, that is x is equal to x1 plus lambda times x2 minus x1. Similarly, y is equal to this component, so y can be written as y1 plus lambda times y2 minus y1, and z is equal to z1 plus lambda times z2 minus z1, right? Now from these three equations we can write x minus x1 is equal to lambda times x2 minus x1. Then y minus y1 is equal to lambda times y2 minus y1, and z minus z1 we can write lambda times z2 minus z1. Clear? Now viewers, again if we write these three equations in the form, see, if we write it like this, x minus x1 divided by x2 minus x1 equal to lambda y minus y1 over this is y2 minus y1 equal to lambda, and then we have z minus z1 divided by z2 minus z1 lambda, right? Now if we write again these equations in in the form of a single equation, then we have x minus x1 divided by x2 minus x1 is equal to this is y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1 equal to lambda. So this is the equation of a line passing through two given points, and here the first point A is x1 y1 z1, and the point B is x2 y2 z2. Here we have x2 y2 z2, right? And this lambda is a scalar, and if we can write this equation in the form, if we remove this lambda, then we can simply write x minus x1 divided by x2 minus x1 y minus y1 y2 minus y1 and z minus z1 z2 minus z1. So this is the Cartesian equation of a line which passes through two given points, and the vector equation is vector r is equal to vector a plus lambda times vector b minus vector a, right? Here viewers, there is one important thing, that is x2 minus the direction ratios of the line of this line L, of the line L are x2 minus x1 y2 minus y1 and z2 minus z1, right? Now viewers, let us take this problem. Here we have to find the vector and Cartesian equation of a line which passes through these 2 points. So here this is point A and this is point B. So this point is x1 comma y1 comma z1, and this point is x2 comma y2 comma z2. So therefore the Cartesian equation is x minus x1. So x1 is minus 1. So here we have minus 1 divided by x2 minus x1. So we have 3 minus minus 1 equal to y minus y1. So we have y minus 0. Here it is 0 y1, and then we have 4 minus 0 y2 minus y1. Then we have z minus z1. So z is here it is z minus z1. z1 is 2, and z2 minus z1 is 6 minus 2. 6 minus 2. So if we simplify this equation, then we have x plus 1 divided by 3 plus 1, that is 4. We have y divided by 4, and then we have z minus 2 divided by 4, right? Here we have 6 minus 2 as 4. Here we have 4, and here we have 4, right? Okay, so this is the Cartesian equation of the line. Now suppose we have to find its vector form, then we will make use of this equation, right? So what we will do, we have here vector r, and what is vector a? Vector a is this. So we have minus I cap plus 0 j cap plus 2k cap, and this is plus lambda, and b minus a, that is vector, this is vector b, and this is vector a. So 3 minus, that is we have here 4i cap plus 4j cap plus 4k cap, right? So this is the vector equation of this line. Now viewers, let us take this problem. Find the vector and Cartesian equations of the lines that passes through the origin and this point 5 comma minus 2 comma 3. So here the origin is the point 0 comma 0 comma 0, and the second point is 5 comma minus 2 comma 3. So this is point x1 y1 comma z1, and this is x2 comma y2 comma z2, right? So the Cartesian equation of the line is given by x minus x1 divided by x2 minus x1, and we have y minus y1 divided by y2 minus y1, and then we have z minus z1 divided by z2 minus z1, right? Now if we substitute these values here, we get x minus 0 divided by 5 minus 0, then we have y minus 0 minus 2 minus 0 and z minus 0, and divided by 3 minus 0, which can be written as x over 5, y over minus 2, and z over 3. So this is the Cartesian equation of the line, right? And here the drs of the line are 5 minus 2, 5 minus 2 and 3, right? Now for the Cartesian equation, for the vector equation, the vector equation can be given as vector r is equal to vector a plus lambda times vector b minus vector a. So here this vector a can be given by this vector, so this is 0 vector, right? Because vector a is 0 I cap plus 0 j cap plus 0 k cap, right? Because vector a is x1 I cap plus y1 j cap plus z1 k cap. So this is 0 vector. So here we have 0 vector plus lambda times vector b minus vector a is given by x2 minus x1 I cap plus y2 minus y1 and j cap plus z2 minus z1 k cap. So here we have 5 I cap plus this is minus 2j cap plus 3k cap, right? So therefore if we simplify it, we get vector r is equal to lambda times of or we can write it as 5 lambda I cap plus minus 2 lambda j cap plus 3 lambda k cap, right? So this is the vector equation. Viewers, now let us consider any line. So here we have the equation, the Cartesian equation of a line, right? This is a line. Now let us draw some conclusions by this equation. So the first one is that find the point through which this line passes, right? Or in other words, we can say find the point from where this line passes through. So if we compare this equation with x minus x1 divided by a, y minus y1 divided by b, and z minus z1 divided by c, then we see that the point x1 comma y1 comma z1 is equal to minus 3, 4 and minus 8, right? And the second one is what are the drs of the line. So the drs of the line are a, b and c, a, b and c, and here the direction ratios of the line are 3, 5 and 6, right? Now suppose we want to find the direction cosines of the line. So what are the direction cosines of the line? So first we will find the expression, that is square root of a square plus b square plus c square, and here it is 3 square plus 5 square plus 6 square, and this is 9 plus 25 plus 36, so this is 34 plus 36, that is square root of 70. So therefore the direction cosines of this line are 3 divided by square root of 70, and then we have 5 divided by square root of 70, and 6 divided by square root of 70. So this is L, this is M, and this is N. And we know that the sum of the squares of the direction cosines is always equal to 1. Right? Now the fourth conclusion is very important regarding this line. Suppose we want to find a unit vector along the direction of the line, So what will be the unit vector? The unit vector will be given by Li cap plus Mj cap plus Nk cap. So the unit vector is 3 by square root of 70 I cap plus 5 divided by root 70 j cap plus 6 divided by square root of 70 k cap. So this is the unit vector which is along the direction of this line. Suppose this is the line L, this line, and this is the unit vector which is along the direction of this line L. Now let us take the equation of a line in this form. Now viewers, here we see that this equation x equal to y equal to z can be written as say x minus 0 equal to y minus 0 equal to z minus 0 and divided by 1 divided by 1 and divided by 1. So this equation and this equation are equivalent equations, right? They are same. So x equal to y equal to z can be written in this form. Now let us draw some conclusions from this equation. So the first one is find the point through which this line passes. So the point x1 comma y1 comma z1 is obviously the origin 0 comma 0 comma 0, because if we compare this equation with this equation, then we see that x1 y1 z1 will be 0 comma 0 comma 0. So this is the origin. So it means this line passes through origin, right? The second one, what are the drs of this line? So if we compare this equation with this equation, we see that A, B and C are 1, 1 and 1, right? The third point is what are the DCs, the direction cosines of this line? So what we will do, we will find the square root of a square plus b square plus c square. So in this case it is 1 square plus 1 square plus 1 square, that is the square root of 3. So therefore the direction cosines of this line are LMN are 1 divided by root 3, 1 divided by root 3 and 1 divided by root 3, right? So the drs of this line are 1, 1 and 1, right? So if we divide the drs by this term, then we get the direction cosines. And also we know that L square plus M square plus N square is equal to 1. Now we want to find the unit vector along the direction of the line. So what will be the unit vector? So the unit vector n cap is Li cap plus Mj cap plus nk cap. So this is 1 over square root of 3 I cap 1 by square root of 3 j cap plus 1 over square root of 3 k cap, right?